Hi students, this is the new topic of chapter 6, applications of vector algebra. In plus 1 we have studied about the vector algebra, the basic concepts, right? Just a recap of the basic concepts. So in vector there are two types of product. One is dot product or scalar product. Right? Consider two vectors, A vector and B vector. Now we want to find out the dot product between these two. So A vector dot B vector is nothing but magnitude of A vector into magnitude of B vector cos theta, where theta lies the angle between A vector to B vector. So this is vector diagram. This is origin. Okay. Right? Here the question may be asked the angle between two vectors, right? This is dot product definition. Suppose we need an angle, means take angle between two vectors. Angle between two vectors is nothing but cos theta. Cos theta is equal to, so taken come magnitude of A into magnitude of B to left side, it will become A vector dot B vector divided by magnitude of A vector into magnitude of B vector. So this is theta. So now I want to find out theta means cos inverse of this. Cos goes to that side, cos inverse. So A vector dot B vector divided by magnitude of A vector into magnitude of B vector. So this is the dot we have studied in the plus 1 itself. So this is a dot product. And one more important property also J. So A vector perpendicular to B vector. So two vectors are perpendicular. Then what about the dot product between these two? So A vector dot B vector, which is equal to 0 if and only if, this read as if and only if. Otherwise we can write simple. Use this symbol also. Okay? When A vector dot B vector, A vector perpendicular to B vector. So A vector dot B vector equal to 0 means if only if A vector perpendicular to B vector. Just think about why it is 0. Because theta is nothing but angle between A vector and B vector. If I take perpendicular vector, consider A vector and B vector is perpendicular, then theta will be 90 degree. Okay, so in cos 90 degree is nothing but 0. So according to the definition, A vector and B vector, which is equal to magnitude of A vector magnitude of B vector into cos 90. Cos 90 0. So 0 into anything or 0. So A vector dot B vector, which is equal to 0 if and only if A vector is perpendicular to B vector. So these three vectors are very important in dot. Three properties are very important in dot product. So another product also is there. Another product is nothing but cross product or vector product. Right? So now we have to use take two vectors, A vector and B vector. Now we want to find out the cross product between these two. Okay? So we can imagine that these are two vectors. This is A vector and this one is B vector. And the angle between these two vectors is nothing but theta. Now we want to find out the vectors. This is nothing but A vector plus B vector. A vector plus B vector is both perpendicular to A vector as well as perpendicular to B vector. So A vector plus B vector is nothing but magnitude of A vector into magnitude of B vector sin theta into n cap. What is the n cap? N cap is perpendicular to the plane surface. Okay, here this is n cap. This is nothing but unit perpendicular vector. Unit perpendicular vector. What do you mean unit? So we are taking magnitude. The magnitude will be 1. That is nothing but unit perpendicular vector. So in dot product we are using cos theta. In cross product we are using sin theta. Okay. So we can find out magnitude of A vector plus B vector means this n can be cancelled. Because of that we are applying magnitude of n vector, which is equal to 1. Since magnitude of A vector plus B vector is equal to magnitude of A vector into magnitude of B vector into sin theta. So the same way we can find theta. I will do this to vector in sine format also, in cross product format. So sin theta, which is nothing but magnitude of a vector plus magnitude of b vector divided by magnitude of a vector into magnitude of b vector. If I take sin theta is equal to this one. So when find theta means sin goes to that side, sin inverse of magnitude of a vector plus b vector divided by magnitude of a vector into magnitude of b vector. So these are the dot we have studied in plus one. Right? Now, we have to go for directly to example sums, right? Now I am going to take example 6.1. This is nothing but cosine formula. This is nothing but cosine formula. We have three formulae, but we are doing only one formula here. With the usual notation, in a triangle ABC, prove that a square which is equal to b square plus c square minus 2bc into cos by vector method. So a square which is equal to b square plus c square minus 2bc is equal to cos A. This is a cosine formula we studied in 11th also in trigonometric chapter, and as well as in 12th physics in dipole. First chapter in dipole concept we have some 5 more question also. We are using r square plus b square minus 2rb cos theta cos 180 minus theta like that. So in physics in dipole concept also we are using. So this is the important formula. But this formula we are going to prove by vector method. So okay, now given only one clue in the triangle. Consider triangle first. Take a triangle here named ABC and mark the interior angle of the triangle should be same. So it is vertex A, its the interior angle B. Its vertex B, interior angle B. Its vertex C, interior angle C. Now we want to prove by vector method. Okay, so now vertex opposite vertex we want to assume there is a vector. So a vector I assume as opposite side of the vertex. So B means this side is a B vector and this means C vector. So vector so it should be extended. A vector means it should be extended. C vector means it should be extended. Now B is an interior angle. What about exterior angle? So this is nothing but exterior angle. Exterior angle nothing but pi minus B, because interior angle B, exterior angle pi minus B, because this is a straight line. In a straight line, full angle is nothing but 180. So this is pi is nothing but 180. 180 minus B. We can write pi minus B or 180 minus B. So this is nothing but A vector, so B vector. So whenever we are marking an angle, only counterclockwise, otherwise anti-clockwise, right? So if interior angle C means exterior angle pi minus C. The same way here also, this one is pi minus C. So this is a closed figure, closed diagram. So in a closed diagram, the sides are representing vector, then the sum of the side of vector is equal to 0. This is universal concept, right? Okay, now we have to go for proofs. In triangle ABC, we have assumption BC vector which is equal to A vector, CA vector which is equal to B vector, and AB vector which is equal to C vector. We are taking the side vectors like this. So in triangle ABC, sum of the sides, that is BC vector, CA vector plus AB vector which is equal to what? 0. So sum of the side vectors is equal to 0. It is A vector plus B vector plus C vector which is equal to 0. So here A square only, A only is there, no? So I want to write only A. So I keep A vector on the left side, taking to the remaining on the right side. So A vector which is equal to plus B goes to the left side minus. So I write minus of B vector plus C vector. Right? Now taking A 0. Okay. So now taking the square values. A vector the whole square which is equal to minus B we cancel, no? So B vector plus C vector is the whole square. Now we simply want to write a plus b the whole square formula. Okay, a plus b whole square, you know very well, a square plus b square plus 2ab. The same thing you want to write here. What about left side? So a square which is equal to, here I mean we have to write vector square, b vector the whole square plus c vector the whole square plus 2 into b vector dot c vector. We are using vector here dot product. So we know very well in the concept a vector the whole square is nothing but a square. This is nothing but magnitude of a vector whole square. This is nothing but a vector dot a vector. So a vector dot a vector is nothing but a square. A vector whole square is also a square. So magnitude of a vector whole square also a square. The same way we are writing here a vector square is nothing but a square. This one is b square. This one is c square. Plus now the definition of dot product will become 2 into magnitude of b into magnitude of c cos of pi minus. Now we want to take the angle between b vector and c vector. Look the diagram here. So this is b vector and this one is a c vector. The exterior angle, so b goes to here, no, b vector, the angle between. So angle you have to mark anti-clockwise. So starts from b, so b to c. So the angle should be pi minus a. So you have to write cos of pi minus a. So now a square which is equal to b square plus c square here plus 2. Magnitude of b vector nothing but b. Magnitude of c vector nothing but c. Cos of pi minus a is nothing but minus cos a. So the minus plus will be multiplied with this one. We get a square which is equal to b square plus c square minus 2bc into cos a. So this is required cosine law. So remaining sums we can do like this. Okay. Now I have to explain why cos pi minus a is equal to minus cos a, because this is the rule ASTC. Just recalling plus one trigonometric concept ASTC. Here 180 minus theta. So this area should be 5 minus theta. Here the 1 minus pi minus a lies in second quadrant. So second quadrant place with only sign. If it is a sign theta and the cosine theta only positive values. Remaining ratios are negative values. That is cos of 180 minus theta which is equal to minus cos theta. Just recall the concept. You get cos of pi minus a is equal to minus cos a, hence the result was over. Okay. So remaining two sums we can do like this. Thank you. Students, this is example 6.2. Then there is a projection formula. This formula also studied in plus 2 trigonometry chapter. Now we have to prove a is equal to b cos a plus c cos b. The projection formula through vector method, right? So the given the same way one triangle is given, triangle ABC. Now to take the triangle ABC, name the vertex ABC, and take the interior angle A, and this one is B, and this one is C. Now take the vectors. Opposite the vertex is nothing but A vector. So B taken, this one is a B vector. C, this one is a C vector. Okay, opposite vectors nothing but C vector. This is vector, so it should be extended, and this also should be extended, and this also. So now exterior angle is nothing but pi minus b. This exterior angle is nothing but pi minus c. This exterior angle is nothing but pi minus c. The same proof before some example 6.1 same as it is you want to do. Okay. So now proof of let BC vector which is equal to A vector, CA vector which is equal to B vector, BA vector, sorry, AB vector which is equal to C vector. In a closed figure, closed diagram, the sum of the side vector is equal to 0 vector. Sorry, here interior and A will so 5 minus A, right? So sum of the interior and sum of the sides of the closed diagram should be what? It's 0 vector. So we know very well. So BC vector plus CA vector plus AE vector which is equal to what? 0 vector. So here A vector plus B vector plus C vector which is equal to 0 vector. So here A only right left side, remaining terms are right side now. So just to keep A vector is left side, take and go the remaining two vectors to right side. It will come minus B vector and minus C vector. Now dot product with this A vector to both sides, right? A vector want to multiply with A vector dot operation. in both sides. So a vector dot a vector here minus into a vector dot b vector, here a vector dot c vector. So multiple with a vector dot on both sides. So a vector dot a vector is nothing but a square. Here, according to dot product definition, magnitude of a vector, magnitude of b vector, cos of a vector dot b vector. So I am bringing a vector to b vector. A vector here, b vector here. So I am bringing these two. I think that is what the count is. So this is nothing but pi minus c. So pi minus c minus here magnitude of a vector, magnitude of c vector. I will bring a vector and c vector. This is a vector, this is c vector. So I will bring this one pi minus. Sorry, cos of pi minus b. So now we below level cos of 180 minus theta is equal to minus cos theta. Cos of 180 minus theta is nothing but minus cos theta. So hence we can apply here. So a square is equal to minus a into b into minus cos theta. Cos theta right inside the bracket. Okay. So here minus of a into c into cos of minus cos of b. So this minus when multiple with the symbols, it will be plus. So here also plus. So a square is equal to ab cos c plus ac cos b. Now divided by a on both sides, we get a is equal to b cos c plus c cos b. So this is projection formula. The same way you keep b left side, remaining terms right side, or c left side, remaining terms right side, you get another two projection formula also we can solve it. Okay. This is example 6.3. Cos of alpha plus beta is equal to cos alpha cos beta minus sin alpha sin beta. So this is already in trigonometric formula. We studied in Algebra also. But now this formula we want to prove by vector method, right? So book method is different, and my teaching method also different. So now I am going to take a unit circle. With the unit circle means the radius should be 1. That's the radius is 1. And mark coordinate axis, x-axis, y-axis. Then I vector and j vector to be unit vectors acting along x-axis and y-axis respectively. I am taking a point A and B on first quadrant as well as fourth quadrant. So this is center O, and it makes an angle alpha with the x-axis, and it makes an angle beta with the x-axis. Now the angle between AOB is nothing but alpha plus beta. Now I want to mark the coordinates of A. So just draw AM is perpendicular to x-axis and BM to perpendicular to x-axis. Now consider this triangle, right? Just I can explain only one triangle, you can follow this one. This is one triangle, so OM A. So this is alpha. This is the unit circle. So OA, the radius should be 1. So any point can mark as x comma y in coordinate system, right? In coordinate geometry, we can mark because to So now this is x comma y. So this distance should be y. Now I want to find out the x values, y values in trigonometric ratios, right? So I am applying trigonometric ratios here. This is hypotenuse side, and this is opposite side, and this one is adjacent side. So I put cos alpha here. Cos alpha is equal to adjacent divided by hypotenuse. Hypotenuse side is nothing but one adjacent side is nothing but x. So x is equal to cos alpha. Next, sin alpha is equal to opposite divided by hypotenuse. Hypotenuse value is nothing but 1, opposite nothing but y. So y divided by 1, which is equal to 1. So the point A is nothing but cos alpha comma sin alpha. In the same way, B also cos beta comma sin beta, but here the point lies in fourth quadrant. So second point is minus. Otherwise, we can say the OP, you have to cross OB, since it passes from OM to NB, so directions of the J vector is opposite. So due to the opposite direction, you have to go to minus R. So it's an opposite thing. Okay? Right. Now the details you have to write in the representative in direct format. Now I am writing a proof. Consider the unit circle. Okay, consider the unit circle. Take A and B points on it. Take XOP, EY, XOP, AYX, write AYX or XOA is equal to alpha, and XOP which is equal to beta. It seems that angle AOB which is equal to alpha plus beta. And I vector, J vector be the unit vectors acting along the x-axis and the y-axis respectively. Therefore, the coordinates of A cos alpha, sin alpha, and B cos beta, minus sin beta. So now we are going to represent in OA vector, right? Now I want to represent OA vector, so I want to go for OA vector like this. So first I want to go to OM vector, then further MA vector. So OM vector plus MA vector. OM is nothing but horizontal. Horizontal value, horizontal means x. X is nothing but cos. M to A is nothing but vertical. Vertical value is nothing but y. So y is nothing but a sin alpha, right? Now this is cos alpha and this is sin alpha. But this is a vector, you know. In horizontal, I vector acting, vertical J vector is acting. So you want to represent vector also. So cos alpha and I vector, sin alpha and J vector. Now this is OB. So OB, so I want to go to OA first. OA vector plus NB vector. The same way here, OA is a horizontal distance. This is nothing but cos beta, and this one is sin beta. Distance always positive, so you have to take sin beta. But horizontal acting vector is I vector, but vertical distance acting J vector, but this direction should be reversed, hence you get minus here. Sin beta and J vector. This is OB vector. Now we have to find out the angle in these two vectors. So the angle lies only OA and OB. So overall angle should be alpha plus beta. So now I want to find the OA vector and OB vector. So OA vector, OB vector is equal to cos alpha I vector plus sin alpha J vector into cos beta I vector minus sin beta J vector, which is equal to multiple with the I dot I, you know I dot I which is equal to 1, right? So the same way I dot J equal to 0, because unit vectors first of all second perpendicular to each other. So if two vectors are perpendicular, then dot product will be 0. That's right. So I want to only multiply with I. So cos alpha, cos beta, plus it minus sin alpha into sin beta. So this is OA vector and OB vector. Now by definition, OA vector dot OB vector which is equal to magnitude of OA vector, magnitude of OB vector. The angle between OAB is nothing but alpha plus beta. So this is the dot product. So we are using cos. So cos of alpha plus beta. So OA and OB, this is a unit circle. It has length OA length 1 and OB also 1. Because OA OB which is equal to 1. That is unit circle, right? That is unit circle. So this is nothing but cos of alpha plus beta. This is equation number 2. So here OA and OB which is equal to cos alpha cos beta minus sin alpha sin beta. Here also OA and OB which is equal to cos alpha plus beta. From 1 and 2 we get cos of alpha plus beta which is equal to cos alpha cos beta minus sin alpha sin Next example 6.4. With the initial rotation in the triangle ABC, prove that A by sin A equal to B by sin B equal to C by sin C in vector method. Okay. So now we want to draw a triangle. Name it as A, B, C. The same diagram, same representation only. So this is interior angle A, this interior angle B, and interior angle C. So no need to take the angles also. Just to take the A vector and the B vector and C vector. It's enough. Now by property, I am going to do here by area property of triangle ABC. Area of triangle ABC is nothing but half into AB vector cross BC vector. Otherwise, half into BC vector cross CA vector. Otherwise, CA vector cross BC vector. We can choose any one. Okay, because any one formula. This you are taking this one. This is nothing but area of triangle. So this value is equal to this one. This value is equal to this one. Now half will be cancelled. So AB vector, under assumption AB vector is equal to C vector, BC vector is equal to A vector, CA vector is equal to B vector. You are applying here. This is C vector plus BC nothing but A vector. Here BC A vector cross CA B vector, which is equal to CA vector. CA is nothing but B vector. And BC is nothing but A vector. Okay, CA, B vector, and CA with AB, ABC vector. CA and AB. Okay. Now, so this is definition of magnitude of cross product. So we can write magnitude of C and the magnitude of A. The angle will be sine of C to A. So in simple, C is present, A is present. So B is absent here. We can write phi minus B. That means the angle will be A vector and C vector. So A vector and C vector we want to take the exterior angle only. So we have to take phi minus B here. Okay. So here also, so magnitude of A vector, magnitude of B vector. This is cross product. So it will present sign. Here A, B is present, C is absent, so we must be shortcut. So the exterior angle should be pi minus C. Here also magnitude of B vector, magnitude of C vector. So sine because of cross. So the angle will be BC. So B is present, C is present, A is absent. Just choose that is pi minus A. So sine of 180 minus theta, which is equal to sine theta, because the 180 minus theta lies in second quadrant. So second quadrant sine home. Okay, sine house. So sine cosine plus remaining ratios are minus. So magnitude of C is nothing but C, magnitude of A is nothing but A, pi minus B is nothing but B. So sine capital B. Here small A B into sine of capital C. Here B C sine capital B. Now divided by ABC or divided by ABC. What do you get? CA sin B by ABC, which is equal to AB sin C divided by ABC, which is equal to BC sin A divided by ABC. So CA cancel, AB cancel, BC cancel. So we get sin B divided by B. Here sin C divided by C. Here sin A divided by A. Taking reciprocal and arrange this one. Taking reciprocal and arrange. So we get A divided by sin A, which is equal to B divided by sin B, which is equal to C divided by sin C. Okay.